In today's lesson, we're going to expand our view a little bit about the different kinds of probabilities that we can calculate related to the z-scores and the standard deviation that we looked at before, but not necessarily things being grouped quite as nicely. So before, when we looked at our normal distribution, we had the curve like we have the picture on the notes, and we had our divisions where we had like our 34%, so 68% of our data was within one standard deviation or of z-score of positive or -1. We had our 13.5, and we had, let's see, 2.35, 2.35, and our last 0.15%. And so this is what we usually think of, again, as our standard normal probability distribution. But if we're looking at scores that don't hit at quite as nice places, so if we had a value that hit somewhere in the middle, but not exactly, how do we figure out the percent probability of a data point occurring below or above that location? And so that's what we're looking at today. Now, there are three different ways that we could do this. I'm going to be focusing on using Desmos. Reason being is that is the calculator that you're going to have available if you have to take the SOL. It's the most straightforward way to calculate these probabilities. That being said, you can use a TI graphing calculator. And I do have a summary on this page with how you can do these problems on that calculator. Let me shrink this down a little bit. So that's your first column in the chart. Second column is the Desmos rules or steps that we're going to be following as we do our examples today. And then there's also a z-score chart that's provided on the SOL. And if you open the organizer file, you can actually click on that link and it will take you right to that z-score chart, or open the packet of notes that I put at the beginning of the unit, and it has that same chart. And those are all the values that are saved in Desmos and in your graphing calculator. And in fact, this is the way that we had to do these problems, back when I was in high school and college, because we didn't have easy access to a graphing calculator or a calculator as robust as Desmos to look these up. So any of these methods would work. If you have questions about using each one, let me know, absolutely. And I can either forward you to a good, place to look at, or, show you how to use those. I do have to admit, I don't have a TI graphing calculator with a newer operating system, but I do have a virtual calculator with the older operating system. So anyone with a TI 83 plus or TI 84 plus, not the color editions, not the skinny calculators, but the larger calculators, I can absolutely show people how to use those. But we're going to focus on using Desmos for this. So here's your reference, but honestly, seeing how to set these up is going to help the most. So let's just jump right into our problems. So I need to move around with my screen. And again, you've already probably noticed I'm sharing my entire screen because this is what I'm going to do. I'm going to have our sheet with all our problems kind of side by side with our graphing calculator. So if you don't already, I would absolutely put this video in full screen mode so you can see what I'm going to be doing in each piece. Alrighty, so first set of problems. We are going to calculate each probability. So we did this before just by adding up the percentages in the different sections. And so let's start this out just so we can kind of compare with what we did before and see what makes sense with plugging these into the Desmos calculator. So our first one is we want to find the probability that our z-score is less than 0. So in other words, what are all the things that are below a z-score of 0? And so don't forget, z-score of 0 means you're right smack in the middle of your graph, which means half your data points are right below. So we should get out an answer of 50 on this when we plug it in. So here's how we plug this in the calculator. So you start your line. You want to make sure that you open your keyboard if it doesn't automatically. Mine automatically opens up because I'm actually on a touchscreen computer right now. But you can absolutely use your keyboard as you're typing other things in. So two ways to do this. You could actually go to Functions and then go to DIST for Distributions. And then you're going to click Normal DIST. Now you could just type in this word and that would work as well. Either way, it's going to pop up as soon as you type that parenthesis or as soon as you hit the button from Functions. It's going to have this set of parentheses. And because all they gave us in this example was just a z-score, we're working with just the plain old standard probability or standard distribution. We don't know, any extra values for a mean or a standard deviation. So we're just going to plug in a 0 and then a comma and then a 1. And so that's saying we're just looking at a plain old standard distribution with a mean value of 0 and a standard deviation of 1. So next, you need to click the box that says find cumulative probability, so the CDF. So check that box and you have a minimum and a maximum value. And so you need to type in what's the lower bound of the scores you're looking at and the higher bound of the scores you're looking at. So this first one, we're looking for the probability that Z is less than 0. So if we think about this in terms of more like almost an end behavior or a range, that means we're going less than 0 means we have to go from negative infinity up to 0. So that's what I'm going to type in for my minimums and maximums. My minimum is negative infinity. And you'll actually notice the calculator, that's the default value for the minimum. And then my maximum is going to be the 0. So I just need to type into that spot 0. There we go. Alrighty. And so again, it is popping up with my keyboard on my touch screen. That's okay. And so as soon as I type that in, I get the number 0.0 or 0.5. And so 0.5, we'll change that into a percent by moving your decimal back over 2 places. That means we have 50% of our data is below Z equals 1 or Z equals 0. So that half graph. So another way to kind of connect this to our normal distribution, you see that little plus sign that we have right to the left of what we typed in. Go ahead and hit that. And it actually pops up and kind of zooms in on our actual distribution curve. So it's showing us, hey, we're looking at everything below a z-score of 0, which means it's shading in everything below that point. So that's kind of the area under the curve that we're finding. Okay, next one, P of z greater than 3. So that means we want to go all of our values with a z-score 3 or bigger. So that means we're going to go from 3 up to infinity. So 3 is our min, infinity is our max. Same kind of distribution, so I'm not going to retype anything except for my minimum and my maximum. So my minimum now, I need to type that in as a 3. My maximum, to go up to infinity, all I'm going to do is delete and hit enter, and it automatically fills in the default value, which on the maximum is infinity, and it gives us that teeny tiny decimal. So we have 0.001349, etc. And just like we were before, I'm going to go ahead and round things to 2 decimal places in my final answer. So that means I've got to move my decimal place over 2 places to write this as a percentage. So this is really 0.13%. And again, if I go ahead and go back to that normal distribution, excuse me, it's already kind of zoomed in. I can't really see it too well, but if I zoom in on that part, that's where we have it shaded in. So it's just that little teeny tiny bit over onto the very right-hand piece of our graph. If we're looking at the whole graph, kind of hard to see where it got shaded in. Okay, last one. Probability that our z-score is between -1 and +1. Again, that's just our min and max that we're going to type in. So again, change the minimum so it's a -1. Maximum, so it's a 1. So there you go. It's even shading it in for us. So again, this was our min, this was our max, and it spit out the value 0.34134, etc. But if I round my final answer to 2 places, that means I'm looking at 34.13%. And if we think about that, oops, that's incorrect. How come? Yeah, double check that maximum value. So that should actually be a 1. So let's update that. Open the keyboard back up. That should be +1. So again, left 1 standard deviation, right 1 standard deviation. It's just that central area. It's giving us a decimal of 0.6827. Because if I round up with my percentage, and again, you'll notice this is a little different than the values that we used before because we were definitely using a generalized version for our standard deviations. Now, officially, we could absolutely use the more exact version that Desmos is giving us. It can just round to more decimal places and kind of give us more accurate values for this. So when in doubt, always use the more accurate version. Alrighty, let's look at our next set of problems. So with this next one, again, same kind of situation almost as the wedding problem. So heights of American males are normally distributed. Let me shrink this down a little bit more. Normally distributed with a mean of 69.3 inches and a standard deviation of 2.8 inches. So a little different than what we had. Again, just depends on our source. So the difference is on this one, they gave us a standard deviation and they gave us a mean. So what I'm going to do is just change up what I have plugged in. So in our spot with normal distribution, in there, all I'm going to do is update those values. So again, the mean has to go first. The mean they told me was 69.3, and then have a comma. And then the standard deviation they told us was 2.8. And again, it's automatically updating the values for us. We just need to make sure that if they give us that information, that's what we plug inside the parentheses. If they don't, then we're just going to use mean of 0, standard deviation of 1, and you'll notice you'll have a z variable in your problem. And so now we're just plugging in our values to see what happens. Okay, so what percentage of males are shorter than 68 inches? Which means what is our minimum? Our lower bound has to be, well, if we're below 68, negative infinity. So our max is going to be 68. So you're going to change your min and your max values. And again, just type in the new values. I'm going to leave this one blank and go right over to the max. And again, automatically fills in negative infinity for me. So top end, the maximum is 68. And so percentage is 0.3212, or if I change that over to an actual percentage, 32.12%. Because I changed my values, you'll notice that little plus sign popped up again. So if I click that, there's my normal distribution with the shading showing the percentage of values we're looking at. Okay, what about males taller than 69%? What percent should that be? So again, all we have to change, minimum and maximum. So now our min is going to be 69. Our max is going to be infinity. So just update your values. Alrighty, and then 68, again, giving me an error message right now because right now my minimum is bigger than my maximum. So it'll let you know if your numbers have to change up. Maximum is infinity, so I just need to get off of that space and it'll pop over back to infinity. And again, looking at our graph, we know we're shading everything above that value of 69, which is just barely below our mean. So 0.5427. Again, why do I keep rounding the decimal to 4 places if I'm rounding my final answer to 2? Because I'm taking into account that I'm going to have to move my decimal place over 2 places to get my percentage. Okay, C, less than 70. Again, same kind of thing as the previous problem. It's just now our max is going to be 70. Our min is going to be negative infinity. Same situation. So again, all I have to do is change my numbers. So min negative infinity, max 70. We have 0.5987. Change to a percentage, 59.87%. And again, 70%, a little bit over the mean, so that's why it's more than 50%. Okay, then how about greater than 71? Okay, what's your min? Well, if you're greater than 71, that means minimum 71, maximum is going to be infinity. So minimum 71, then max, delete that out. Oops. Click somewhere else to get the negative or to get the default. So 0.271, I'm going to round up because the next one's a 7, which equals 27.19%. And again, that kind of goes with the data we were looking in the other problem. You know, anyone that's above that 69.3 inches, again, you're looking at the higher end of possible height. So you're going to have fewer people the higher you go. So how do problems E and F look different? So with our notation, part C and D had the X in there. So they were talking about the actual scores of our values, whereas in part E, they changed it over to Z. So that means we're just changing right back over to standard normal distribution. So I need to change my values inside the parentheses to mean of 0, standard deviation of 1, and now everything is just going to reference Z-scores. Okay, and so this is where we can start dealing with those funky Z-scores. Usually, last class, we were looking at the nice integer ones, +3, -2, what have you. Well, now I have a minimum Z-score of -3.05 and a maximum of 1.55, and it really is just as simple as plugging it in the calculator, and it calculates it for you. Again, just to get an idea of where these are, again, Z-score -3.5 is going to be way down to the left. 1.55 is going to be a little bit up towards the middle. Hit the little plus sign to zoom in. There's our shading happening. Awesome. So decimal is 0.9383 if we're rounding, so 93.83%. Okay, Z-score less than -1.2. Can you predict your percentage around what it might be? Well, automatically I know it's negative. It's past -1, so it's going to be a little smaller than whatever 50 minus that 34% chunk is. So again, make sure you're aware of your minimum and maximum. Okay, minimum, if you're less than a number, means minimum -infinity. Max is the number you're looking for. So minimum -infinity, maximum -1.2. And again, as soon as I move over to a different space, it fills in that default value, so I don't actually have to type in -infinity or +infinity each time. So we have 0.1151, aka 11.51%. Alrighty. So if you need to take a quick stretch break, now might be a good time to pause the video before we get into the second piece of what we're looking at, which again is kind of analyzing percent values. Alrighty, so here's what our next expression is going to be. So finding the percentile of a specific data value. So you've probably heard of things, and if you've taken PSATs, you know, when they give you your score reports, they might have said you're in the 90th percentile or you're in the 70th percentile of students that took the test this year. And so what that means is it's finding where you are on that standard normal curve. Basically thinking about, you know, how many standard deviations away are you? And then what percent of people are below on that score. So for example, if you were the 4th tallest person in a group of 20 people, that means that 16 people are shorter than you. Well, that is going to make up 80% of the people in that group. So 80% of the people are shorter than you. That means you are at the 80th percentile of height for that group. So again, this is a lot easier to do on Desmos, but you can absolutely do this on a TI calculator. Again, those directions are in the first piece of the chart. You can also do this with a Z-score chart, kind of old school, looking it up on a table. And again, if you want to check either one of those out, just let me know, and I'd be happy to show you how that works. But again, let's focus on Desmos because this one is the most straightforward. And again, you'll have this calculator both on your test and the SOL that you can use. And you'll notice too, I'm actually using the standards of learning version. So this is the version that is going to be on your test. So you still have all those same features available. Alrighty, so let's look at our examples. So example 3, the heights of American males are normally distributed. Hey, same information. But now we're asking the question a little differently. So we need to start this out almost the same way we did the previous problem. So normal distribution. We need to go ahead and type in our values. So our standard, or excuse me, our mean is 69.3 inches. And our standard deviation is 2.8. Now, here's the kicker. This one's a little different. And actually, let me go ahead and pull this graph over a little bit so you can see better what I'm typing. Whoops. There we go. So the question is, what height is the 90th percentile for the American male height data? So somebody who's at the 90th percent, how tall are they going to be? So we already know they're going to be pretty tall because they're going to be on the very high end of that normal curve. But what's actually the number that we have to use for that? So we have to type this in a little differently. So what you actually need to do is, after normal distribution, we have to tell the calculator basically, hey, I'm looking this up backwards. What's kind of the terminology we used when we were doing functions backwards? We were finding the inverse. So I'm actually going to type in inverse, dot, so where's my decimal point? Dot inverse CDF. And it's going to look a little funky as you're typing it in, but eventually it'll pop over and recognize what you're doing. Now, you've got to put that decimal point before the word inverse CDF. And so all we need to do now is say, okay, here's our standard normal standard curve. We put in our info and say, okay, now look up 90th percentile. So we're just going to say parentheses 90th percent in a decimal, so 0.9. And voila. Sorry, I'm just trying to widen this so you can see it a little better. And voila, it spits out 72.88, or technically, if we round it, 72.89. And so somebody at the 90th percentile is 72.89 inches tall, approximately. So let's write that in. So again, we wrote, let me maximize this so you can see this better. So we wrote normal DIST with our mean, our standard deviation, dot inverse CDF, parentheses 0.9 for that 90%, and it just spit out the answer, 72.89, and in reference to the problem, that's inches. And so it's the same thing as you're doing the rest of these problems. That's all we're doing. We type in that normal distribution, and then we just do the inverse CDF at the end. It'll look up the value for us, kind of doing the problem backwards for us. So height for the 55th percentile, again, normal distribution doesn't change. The only thing that changes is when you type in inverse CDF, you're going to type in 0.55 for your 55th percentile. So when you do that, you should get 69.65. And because the reference we're using is inches. And so what height is the 50th percentile? Again, you should already know what this one is. If we're the 50th percentile, where are we on the curve? Yeah, we're right smack in the middle. So that means we should have 50 come out as our answer, or excuse me, our mean come out as the answer. But test it out. Change it up again. So again, everything ahead of this is the same with normal dist. Inverse CDF, 0.5 for 50%, and you should get out 69.3 inches. Test that on Desmos. Alrighty, last example, example 4, and then after that, I'm gonna kind of split the video. If you need some additional examples, then I'll go through the extra practice that are at the end of the file. But let's just do example 4, and if you need more examples, definitely check those out. Okay, so the weights that we're looking at come from a population that has a mean of 120 pounds and a standard deviation of 15 pounds. So, you know, people that don't weigh a whole lot. Okay, so again, what weight is the 85th percentile? So again, let me pop back over to my calculator. There we go. And so all we have to do is change up the pieces that we typed in. So we need to type in our mean is going to go in this spot. So our mean for this situation was 120 pounds. Standard deviation, that was listed as 15. And then we're looking for which percentile? No, we're looking for the 85th percentile. So that instead of 0.9, I need 0.85. And again, it spits it out as soon as I start typing stuff in. Okay, so again, what we wrote. So this is normal DIST, standard deviation of 20, excuse me, standard deviation of 15, average of 120, dot, inverse CDF 0.85. And again, Desmos will just spit out our answer. So that's 135.55 if we round to the nearest hundredth. And again, I'm usually just rounding to the nearest 2 decimal places because that's a nice standard to go. That's going to give us very accurate answers for the most part. Okay, 5th percentile, what would we have to change in what we type in? Yep, whole front end stays the same. The only thing that changes is inverse CDF. 5th percentile, if you move your decimal place 2 places, so if we had 5% and then move the decimal place left 2, we've got a leading 0. So be careful on those. Okay, go ahead and plug that into Desmos, and it should spit out your answer, 95.33. Actually, I should put an S on there. Okay, what weight is the 20th percentile? Again, so is that going to be greater or smaller than our mean? Yeah, 50% goes at the mean, so 20% means we should expect a value that's smaller than our mean. So again, everything with normal dist gets typed in the same way. We just change the last piece. So inverse CDF 0.2 or 0.20 doesn't matter. It'll interpret both. If you plug that in Desmos, you should get 107.38 pounds. All right, so again, if you need to see this or see some more examples on these, on how I plug things in, with both types of examples that we've worked on, go ahead and watch the next video. Otherwise, you can jump right into your practice.